We begin our next unit G that talks about exponentials and polynomials with objective 38. Objective 38 talks about exponents, negative exponents, and the zero exponent. Let's begin by defining what an exponent is. An exponent can be written in the form x to the a, where x is the base and a is the exponent. What does that mean? X to the a means x multiplied by itself a times. So an example of that, if we have 6 raised to the second power, or raised to the 2, then that means 6 multiplied by itself 2 times. So we would write this out, 6 times 6, where this would be 2 times. Well, we know 6 times 6 is 36. Let's practice. For these, you may use a 4-function calculator. 3 to the third means 3 times itself 3 times. We follow order of operations, so we multiply from left to right. So 3 times 3 is 9. I'll bring down the times 3. 9 times 3 is 27. And that's our answer. Next up, we have negative 2 to the 4th power. That means negative 2 times itself 4 times. Negative 2 times negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is positive 4, and I'll bring down the rest. Times negative 2 times negative 2. 4 times negative 2 is a negative 8 times negative 2. And negative 8 times negative 2 is positive 16. Next up, we have 4 to the 1, or 4 times itself 1 time. Well, if it's just times itself 1 time, it's just itself, 4. Anything to the 1 power is itself. Last, we have 5 to the 2nd power, or 5 squared, means 5 times itself 2 times. So we have 5 times 5 is 25. Next up, we've got negative exponents. Negative in the exponent flips the fraction. A negative flips the fraction. And we've got a special name for that in math. We call that the reciprocal. A note, it does not make the term negative. This is one of the biggest mistakes that we see students make. It does not make the term negative. Let's see how negative exponents operate. Here we have 5 to the negative third. The negative exponent tells us to flip the fraction. Now we can always write things as a fraction over 1. So we can write this over 1. The negative exponent makes us flip the fraction, and then we can drop the negative. So 5 to the negative third is 1 over 5 to the third, the positive third. And this, 5 to the third, we know how to evaluate. We can rewrite that as 5 times 5 times 5, 3 times. And that's all in the denominator of our fraction. We evaluate. 5 times 5 is 25. So we have 1 over 25 times 5. And we know 25 times 5 is 125. and that is our solution. Here we have 2 to the negative second. Again, we can always write numbers over 1, and then we flip the fraction and make the exponent positive. So this is the same as 1 over 2 to the positive 2. We know 2 to the positive 2 means 2 times itself, 2 times. And we know 2 times 2 is 4. So our solution, 1/4. Lastly, we have 4 to the negative 4. We put it over 1 and we flip the fraction. So we have 1 over 4 to the positive 4. 4 to the positive 4 means 4 times itself 4 times. 4 times 4 is 16. And 16 times 4 is 64. And 64 times 4 is 256, which is our solution. Again, you may use a 4-function calculator to evaluate some of these exponents. All right. On the following page, we talk about the zero exponent. The zero exponent is quite simple. Anything raised to the 0 power is 1. It's that simple. So an example, 9 to the 0 is 1. Z to the 0 is 1. We can even group entire terms together. So if we have 5x, y, z, if that's all raised to the 0, that's equal to 1. Let's practice. 5 to the 0, that's just 1. X to the 0, and x can be anything, is just 1. Here we have 2 to the 0 is 1, plus 3 to the 0, which is also 1. So we get 1 plus 1, which equals 2. And that's objective 38. We'll practice this in class.